All right, we're going to start with our patterns. We're going to go into input-output tables. So one thing that I tell our kids, or tell my kids to write in their journals, is to write whether their numbers are increasing or decreasing. So some little notes that you can have them write in their journal before you get started is if your patterns or if your input-output tables are increasing, that means if going from left to right or top to bottom, if the numbers are increasing, they're either going to add or they're going to multiply. And I'm sorry, this keeps going in and out. I use my numbers. If the numbers are increasing, if they're getting bigger, they're going to add or multiply. Okay, if the numbers are decreasing, they're going to subtract or divide. So if the numbers are getting smaller, so increasing is bigger, the numbers are getting bigger, decreasing, the numbers are getting smaller. Okay, so those are the notes or the little tidbit information on input-output. But let's go ahead and get to our input-output table and see how we're going to use that to solve. We have each number in the input set is related in the same way to the number below it. So what does that mean? We've got an input set and it is related in the same way. So that means whatever I do to the top or whatever I do to my input, I have to do to the next one to get the output, the next one to get the output, and the next one. Okay? And related to the same way to get the number below it. So if I do something to 18 to get to 21, I have to do the same thing to 39 to get to 42, 80 to 83, and 57 to 60. So let's take a look. We're going from input to output. The question says, what is the rule for relating the numbers in the table? So what is the relationship between 18 and 21? Well, let's take a look. If I go from 18 to 21 on a number line, am I increasing or am I decreasing? Am I getting bigger or smaller? So 18 to 21, I am increasing. So if I'm increasing, I already know I'm going to add or multiply. Let's always try adding first. So 18 plus what gives us 21? And you can write that out. 18 plus what equals 21? 18, 19, 20, 21. So 18 plus 3 equals 21. Let's see if that works for the next one. 39 plus 3, does that equal to 42? Yes. 80 plus 3, does that equal to 83? Yes. 57 plus 3, does that equal to 60? Yes. So we look at our answer choices. Do we have add 3 plus 3? Yes, that's our possible answer. Let's take a look at multiplying. That was our only other choice. If I multiply by what? 18 times 1 gives us 18. 18 times 2 gives us 36, and we've already gone above. So there's no way it can be multiply. In the very beginning, we decided that we were increasing, and it was either addition or multiplication, so there's no way it can be subtraction. And our next answer choice is add 5. What is 18 plus 5? Is it 21? No. So our answer has to be 6. I'm going to do a problem from each page just so you'll have an example from each one. Okay? And I'm sorry I can't get this to stop focusing. Let's try this. Each number set in set X is related in the same way to the number below it in set Y. So set X is related in the same way to set y. So it's going from x to y. Okay, so I'm going from input to output. Whatever I do to 9 to get to 72, I have to do the same thing to 3, 11, and 1. And it tells me right here, find a rule for the pattern. So what do I do to 9 to get to 72? First, am I increasing or decreasing? I'm going from 9 to 72. What am I doing? I am increasing. So I'm either going to add or multiply. 9 plus what gives us 72? Or 9 times what gives us 72? Oh, if I multiply by 8, I get 72. Three times 8 is 24. 11 times 8 is 88. 1 times 8 is 8. Okay, so what did I do? Let's look at our answer choices. Did I add 16? No. Did I multiply by 7? No. Did I add 8? No. Did I multiply by 8? Yes. Okay. Let's take a look at the next page. Sonia created the table below, or the table following a specific rule. Now it's looking for the rule. What do I do to x to get the output? So the output is y. What do I do to x to get to y? Now I'm going, same thing, input to output, but what are my numbers doing? I'm going from 28 to 4. Am I increasing or decreasing? This time I'm decreasing, so I'm either going to subtract or divide. Why? Because the numbers are getting smaller. Okay? So let's look at our answer choices. There's no way I'm going to add. There's no way I'm going to multiply because the numbers are getting smaller. What do I do to x? Do I subtract 9? What's 28 minus 9? Is it 4? No. What's 28 divided by 7? 4. Yes, so that works. 42 divided by 7. That works. 7 divided by 7. That works. 56 divided by 7. That works. So you really have to know your multiplication and division facts, okay, for this to be easier for you. So C would have been my answer. Okay. Here it says apply the rule to find each table to fill in the missing numbers. So it's telling you right here, what am I doing to x? I am adding what? 5. So I'm going to write plus 5, plus 5, plus 5, plus 5, and plus 5. 2 plus 5, 4 plus 5, 6 plus 5, 8 plus 5, and 10 plus 5. Okay, not too bad. This is what you'll see more on your STAR test or on your benchmarks or your CCAs. It says a number in this function machine. So it's a little machine in here. Something happens to that 16 in this machine. This goes in the machine and out goes the 4. So what happens to that 16? So I'm looking at it. It says a number put in this function machine changes according to a rule. Which best describes the rule for this machine? The number in equals the number out. So it's going from input to output. In and out. What do I do to 16 to get to 4? I can see that I'm decreasing, right? I'm at 16 and I go down to 4. Decrease means down, so I'm either going to subtract or divide. Boom, right there. I look at my answers. I know for sure I'm not going to multiply. I know for sure I'm not going to add. Let's try divide by 4. 16 divided by 4 equals 4. 23 divided by 4 is 11? No. 4, 8, 12, 16, 20, 24. 4 can't even go into 23. So that does not or cannot work because it has to work for all of them. Subtract 12. 16 minus 12, 4, yes. 23 minus 12, 11. Let's see. 23 minus 12, 1 and 1, yep. 31 minus 12, yep, 19. So our answer is what? Subtract 12. Okay? You have to work out the problems. You can't just do whatever. And some kids would have chosen divide by 4 because it works on the first one. Oh, that's my answer. But they didn't check it for this one and this one. It has to work for all of them. Okay? The same thing goes for the next page on the back. But I do want to go over this one because sometimes decimals just kind of like, freaks us out. Don't freak out. Ready? The number in to the number out. So I'm going from left to right. What do I do to 3? I'm going from 3 to 19 and 4/10. Look at my whole numbers. 3 to 19. I am getting bigger. I'm increasing. So I'm going to add or multiply. Look at my answer choices. I have add, subtract, and subtract. So I know for sure I'm not going to subtract because my numbers are getting bigger. So now I've got 13. 13.0 plus what? 3. This is what confuses kids. Where do I put that 3? It's a whole number, so it goes under the 3. 0, 6, 1, 16. Does that work? No. Let's look at 16.4. 16.4 plus 3, 19.4. That works. 16.4 plus what? 14. 4013, 30.4, that works. 16.4 plus 18. Did I get it? Yes, so my answer is B. Let me make sure on the back. The back is the same. The only difference here is now instead of using input output, it is using objects. So triangular prisms and edges. You always want to look at your answer choices to make sure that it's going from left to right or right to left. So here it's going from triangular prisms to edges. Triangular prisms to edges. 4 to 36. Okay? And I think that's about it. The only difference, like I said there, it's their objects. They aren't, it doesn't say input, output anymore. Thank you so much for your time.